Welcome to another video. In this video, we are going to explain in detail how to prove trigonometric identities. In proving trigonometric identities, these are the basic identities that we need to remember. The first one is the reciprocal identities. In reciprocal identities, we have sine theta is equal to 1 over cosecant theta, cosine theta is equal to 1 over secant theta, and tangent theta is equal to 1 over cotangent theta. The second one is the quotient identities. In quotient identities, we have tangent theta is equal to sine theta over cosine theta, cotangent theta is equal to cosine theta over sine theta, and in Pythagorean identities, we have cosine square theta plus sine square theta is equal to 1, and we have 1 plus tangent square theta is equal to secant square theta, and cotangent square theta plus 1 is equal to cosecant square theta. So these are the basic identities that we need to remember in order for us to prove trigonometric identities. So let's start and let's have an example. On the first example, we are going to prove secant theta multiplied by sine theta is equal to tangent theta. In proving trigonometric identities, we need to identify first which part of the equation is more complicated. As you can see in the given example, the left side of the equation is more complicated. So we are going to start working on the left side of the equation. So secant theta is equal to 1 over cosine theta. And we are going to write sine theta. 1 multiplied by sine theta, that is sine theta over cosine theta. Therefore, sine theta over cosine theta is equal to tangent theta. So therefore, we proved that secant theta multiplied by sine theta is equal to tangent theta. On the second example, we are going to prove cotangent theta multiplied by secant theta is equal to cosecant theta. We all know that cotangent theta is equal to cosine theta over sine theta. And secant theta is 1 over cosine theta. So let us cancel this one. And we are going to have 1 over sine theta. And 1 over sine theta is equal to cosecant theta. Therefore, we prove that cotangent theta times secant theta is equal to cosecant theta. On the third example, we are going to prove cosecant theta over secant theta is equal to cotangent theta. Since the left side is more complicated, let us simplify the left side of the equation. So cosecant theta is equal to 1 over sine theta divided by secant theta, that is 1 over cosine theta. And let us simplify. So 1 multiplied by cosine, that is cosine theta. Sine theta times 1, that is sine theta. And we all know that cosine theta over sine theta is equal to cotangent theta. So therefore, we prove that cosecant theta over secant theta is equal to cotangent theta. On example number 4, we have 1 plus tangent theta over cotangent theta is equal to secant square theta. So since the left side is more complicated, let's start working on the left side of the equation. So we have 1 plus tangent theta, that is sine theta over cosine theta, over cotangent theta, that is cosine theta over sine theta. And let us simplify. So since we have sine multiplied by sine, that is sine square theta over cosine square theta, that is cosine times cosine. And then, since we have the denominator cosine, let us write cosine square theta. Cosine square theta times 1, that is cosine square theta plus sine square theta. And we all know that cosine square theta plus sine square theta is equal to 1 over cosine square theta. Therefore, 1 over cosine square theta is equal to secant square theta, because cosine is 1 over secant square. If you're going to simplify, we are going to have secant square theta. Therefore, we prove that 1 plus tangent theta over cotangent theta is equal to secant square theta. On example number 5, we are going to prove cosecant square theta over 1 plus tangent square theta is equal to cotangent square theta. Since the left side of the equation is more complicated, we are going to simplify the left side of the equation. And as you can see, each trigonometric expression is being raised by 2. That means we are going to use Pythagorean identities. So let us rewrite first cosecant square theta, because 1 plus tangent square theta is equal to secant square theta. And cosecant square theta, that is 1 over sine square theta, over secant square theta, that is 1 over cosine square theta. And let us simplify. 1 multiplied by cosine square theta, that is cosine square theta. And sine square theta multiplied by 1, that is sine square theta. Therefore, cosine square theta over sine square theta is equal to cotangent square theta. Therefore, we prove that cosecant square theta over 1 plus tangent square theta is equal to cotangent square theta. On example number 6, we have 1 minus sine square theta over secant square theta is equal to cosine cube theta. We all know that cosine square theta plus sine square theta is equal to 1. If we are going to transpose sine square theta to the side of 1, we are going to have cosine square theta is equal to 1 minus sine square theta. Therefore, the value of 1 minus sine square theta is cosine square theta. So we are going to have here cosine square theta over secant theta, that is 1 over cosine theta. So let us simplify. Cosine square theta multiplied by cosine, that is cosine cube theta. Therefore, we prove that 1 minus sine square theta over secant theta is equal to cosine cube theta.